Hi viewers, in continuation to the last session, in this session I am going to deal with differential elements in cylindrical coordinate system. The coordinates in cylindrical are rho, phi, z, and here the differential elements are d rho, d phi and dz, as rho is incremented with d rho, phi with d phi and z is incremented with dz. So let us construct the cylindrical cuboid with the help of the differential elements d rho, d phi and dz. So this is the fundamental coordinate system x, y, z. X, y, z. As we know that x is incremented with dx and y with dy, as we have seen in the Cartesian coordinate system. The resultant of x and y is nothing but, by constructing the parallelogram, the resultant of x and y is nothing but rho. So this is rho, and this rho is making an angle of phi with respect to x-axis. As we are dealing with differential elements, here rho is incremented with d rho. So d rho is formed due to resultant of x plus dx and y plus dy. The resultant of x plus dx and y plus dy. By constructing a parallelogram, we are going to get d rho. So here also we can say that rho is incremented with d rho. If this is rho and here the rho is incremented with d rho, and if rho is incremented with d rho, phi with d phi. So if this is rho incremented with d rho and phi with d phi. So here this is phi and now it is incremented with d phi. Now taking rho as radius, O as center, we can draw a circle here like this. And taking rho plus d rho as radius, you can draw one more circle here. Then you can get two curved surfaces here facing to d phi. And let us indicate the 4 points here. These 4 points are projecting towards z-axis with a distance of z distance along z-axis. Now joining all the 4 points, we are going to get these two lines are parallel to y-axis, and there will be two curves. You joining these 2 points, you are going to get two curves and all these 4 points are projecting to z. Now again, as rho is incremented with d rho, phi with d phi, then finally z with dz. If this is z, this is incremented with dz. So here all the points in the 4 points are again incremented with dz along z-axis. So let us increment all the 4 points the distance of dz towards z-axis. Then we are going to get, again this is y-axis parallel to y-axis. Again there will be two curves. So we are going to get a cylindrical cuboid consisting of, this side is dz, and the side we are going to get opposite to d phi. This side is nothing but it is like this. If this is rho and the angle made by differential element d phi, and if the radius is rho, then it will be forming like a sector. The length of the arc is nothing but radius into differential angle. So the length of the arc is obtained by using this formula rho into d phi. So this arc length will be rho into d phi. And the length parallel to z axis dz, and the element parallel to y axis is d rho. So finally we got the differential elements are d rho, rho d phi and dz. And here in this cylindrical cuboid there will be 6 surfaces. The surfaces are like this. There are total 6 surfaces. Front and back are similar. Left side and right side are similar. Top and bottom side are similar. So we can find out the differential length in cylindrical coordinate system as dl bar is equal to d rho in the direction of aero cap plus in the direction of phi there will be rho d phi, and similarly in the direction of z there is a differential element of dz. Then the differential surface area means there will be 6 surfaces here. One is front and back surface. This is back surface. This is front face. Front surface, back surface. Both are similar, identical. And these two are lying in rho and z axis. So we can write rho d rho dz. This plane is perpendicular to a phi cap. And the differential surface area, if you see, for left and right surface, for left and right, there will be two curves here for left and right, and the vertical length. So for left and right, these are the two curved surface and two vertical surface, vertical length. So vertical length indicates dz. The curved surface is differential element is rho d phi. So therefore rho d phi dz, which is perpendicular to a rho cap. Similarly, for top and bottom surface, if you are seeing from the top, the plane lying in rho and the curved surface a phi cap. So when the curve is lying in rho and phi direction, the differential elements are rho d phi and d rho, which is perpendicular to a z cap. And the differential volume can be obtained, which is a scalar quantity, by multiplying all the differential elements d rho, rho d phi and dz. So therefore d rho dv is equal to rho d rho d phi dz. This is the differential volume.